Welcome to clickmyproject.com. Our project title: Scalable Algorithms for Nearest Neighbor Joins on Big Trajectory Data. Our project abstract: in this paper, find the trajectory based on the k nearest neighbor algorithm. Our approach is based on joins on two sets of trajectories generated by the two sets M and M of moving objects. For each entity in M and join return in k nearest neighbors from R. We examine how this query can be evaluated in cloud environments. This problem is not trivial due to the complexity of trajectory and the fact that both the spatial and temporal dimensions of the data have to be handled. We also develop a novel bounding technique which enables trajectory to be burned in parallel. Our approach can be used to parallelize the existing single machine trajectory join algorithms. We also study a variant of the join which can further improve query efficiency to evaluate the efficiency and the scalability of our solutions. We have performed extensive experiments on large real and synthetic datasets. Our project flow diagram. In this project, we are developing the trajectory finding using an k nearest neighbor algorithm. First, load dataset. Load dataset means user load dataset from our computer. Load dataset is based on the user input. We are collecting the travel dataset from the one place to another place, and next one the pre-processing. Pre-processing is removing the empty dataset from our dataset. The pre-processing, if we have the many empty datasets in our dataset, the removing process is pre-processing. Next one is the finding same candidate and different trajectory. We have the many trajectory in our dataset. Trajectory means we are using and travel between the one place to another place. These places have our trajectory. And next one is the time dependent. Time dependent is based on the user selected trajectory. The user starting and ending trajectory we are selecting, and we finding the minimum time between the two travel trajectories. And next one is the single machine algorithm. Using a single machine algorithm to organize the dataset from our database. And next one is the finding user feasible using k nearest neighbor. We finding the time dependent based on the trajectory, and next one is the feasible way for the user. We finding the k nearest neighbor algorithm to finding the feasible user pathway for the travel between the one place to another place. And next one is the view result. The result is displayed in the user. Let's see the demo of our project. First we run the home file. This is our first form. Then start the project. Next, this is the load dataset form. The user choose the dataset from our computer. This is our collected dataset from our user collected. This is our dataset. Next, this is our view data. The user collected data will be shown in this table. This is our starting and ending between the two trajectory. We have the many trajectory. We finding the two trajectory between the possible way for using an k nearest neighbor. And next, this is our pre-processing data. We view the original data. This is our original data. We have the many empty dataset from our dataset file, and remove dataset from our dataset. Pre-processing, view the pre-processed data. This is our original data. This is our pre-processed data. The pre-processed empty dataset will be removed from our dataset. Dataset will be stored in our dataset base. And next, this is our finding trajectory. We have the many trajectory, starting ending trajectory between the travel two places. This is our starting. This is our ending trajectory. Find the way to our trajectory files. And this is our way of travel. This is the three dataset from our file, store the data. The data will be stored in the computer. Next, this is our time dependent. Time dependent is based on the user selecting the two trajectory. This is our user selected trajectory. This is the minimum way. This is the possible way for the user traveling the starting to ending point. Store the data. Data will be stored in the database. And next, this is our nearest neighbor. This nearest neighbor algorithm used to find the possible way for user traveling between the two places. User select the train and view the way. This is our way for user traveling to one place to another places. This is our way. View path. This is our selected path. Our project demo is completed. Thank you for listening.